Okay, so we just heard about like cost savings, and maybe they wanted to know about security hardening. So that's like basically what this talk is about. So this is about container advancements in .NET 8. I'm Rich Lander. I work on .NET Runtime and our .NET Container images, and this is Chet Husk.
Hi, I'm Chet Husk. I'm the PM for the .NET SDK and MS Build and this cool containers feature that we're going to learn more about today.
Yeah, definitely. And so this talk is focused on a repo that we already created called Container Workshop. So almost everything we're going to talk about is in this repo. So if you like take your phone, that's a QR code, and then you can actually get to the repo on GitHub. Okay, so let's. We just got a few slides before we move to demos. So we've been producing container images for almost 10 years. So we've heard feedback from customers and users throughout that whole time. And the things that they've been asking us for are basically this 6 or 7 points. They want images to be as small as possible because registry pull is often part of startup. They want the images to be as secure as possible. That can include non-root, no shell, no package manager. We get a lot of feedback about compliance, so that's like scanning, CVEs, that kind of thing. When we ship our images, they only have a specific set of dependencies in them. Customers want it to be easy to add new dependencies. We've shipped Alpine for many years. That's kind of our small offering that uses the musl libc library, which doesn't work for all code. So if you need glibc, then you've had to use our larger container images. And then last, customers often want to know that they're working with a supported operating system. So we kind of got this provocative statement here, which is that we think that general purpose container images are not the future of cloud apps. So up until now, that's actually what we've been shipping is general purpose container images that really have a lot of components in them. And so one of the things we're going to talk about today is what more constrained, more sort of chiseled container images would look like. Okay, so back to the size conversation. And we're using Ubuntu as the example here. And these are all compressed image sizes. So if you sort of do nothing, you'll get the image size on the left. So this is for a relatively small application. So you do Docker build, you'll get the image on the left. And as you kind of like progressively move down, you get all the way to the image on the right. And you can see that it's like 90% smaller than the largest one there. This is actually all the same app, and it's just little configuration changes you can make. And we're actually going to show this in the demo. So these are the kind of quote-unquote normal container images that we ship. And you can see that continuing to use Ubuntu as the example, and these are all compressed sizes. We start with Ubuntu as 28 megabytes, and then we kind of add all these layers on top. And then certainly for ASP.NET, then you get about 90 megabytes compressed before you build your app on. The SDK is kind of a different thing because you don't host that in prod. And the thing I forgot to show on that slide is the user, unless you do something special, is the root user. So that root user can do anything in that container image. We've been talking about this chiseled offering that we've developed with our friends at Canonical. And so this is actually quite different. So here we've stripped the Linux image to be as small as possible. In fact, there is no Ubuntu layer anymore. We basically have a small set of Linux components. That's what's in those runtime deps. That's what's in the runtime deps layer or image. We're down to like 5.6 megabytes. If you look at the previous slide, that was 46 megabytes. So we've reduced a ton of size. And there's basically nothing extra here. So you don't have to worry about getting CVEs in components you're not even using. And you see here that we ship with another user called app. And so all of these images are rootless. Last, before we get to the demos, you can see here that we also have a native AOT offering. You've probably heard about that in a bunch of other talks. And we actually have some AOT-specific runtime deps image. You can see that those are pretty small, the runtime deps image on the left at 5.6 megabytes. And then we have an actual app, native AOT app. So that container image in total is under 20 megabytes, which is really impressive. We also have customers that care a ton about globalization, so like ICU, TZ data. And so we actually have produced another image for those users that want that. So it's as small as possible while still giving you all those globalization libraries. So we hope people enjoy using that. Okay, enough about the theory. So let's move on to some demos.
Yeah.
So Chet, I just kind of, showed all these fancy charts and everything. I think you should, show the people what this actually looks like.
Let's walk through it. I'm really excited for this. So one of the big themes you were trying to drive home there, I think, was size. So let's interactively start with sort of the default for .NET applications and work our way down.
Definitely.
What I've got here is a very simple C# program that just emits to the output the current operating system we're on and the current architecture we're on. This is a very standard CS proj here. We've got all of the same normal standard .NET 8 flags here, implicit usings, nullable enhancements, all that jazz. We're targeting .NET 8, and we've added one piece of customization here. We've got this package reference to the net build containers package. So I've got this app. I think this app is awesome. I want to go deploy it somewhere that uses containers as the unit of deployment.
Right, and I just saw the package reference version there was 8.0.100. So that means that package actually just shipped yesterday.
Yeah, hot off the presses.
Okay, wow.
So let's containerize this thing.
Yeah, so we're going to need that, make that a little bit bigger.
Yeah, we are going to need that bigger. How about that? So we can actually containerize an application just with the .NET CLI. For those of you that have some experience containerizing applications, you may be familiar with Docker files and the Docker CLI. That's not necessary for .NET. We can help get some of that boilerplate out of the way, and it's super fast.
Right, so there's no Docker file, peel underneath the covers. There's no Docker file there.
I can't show you something because it's not there.
Right, so I'm guessing what happened is you downloaded that image there that's listed, runtime 8.0.
Yeah.
You brought it to this local machine, and then you built the app, put that on top, shoved it on top of that thing, and then we basically have a new container image, and that's it.
That's exactly right. There are a couple sort of key points to dig into there, and one of those is what base image you should run with. This is where the SDK can really help out. The SDK knows information about your project. It knows if you're a web application or a console application, or if you've opted into some of our new deployment mechanisms like trimming or AOT. And based on all of that information, it can choose the best image for you. In this case, because we're a console application, we've chosen the runtime image, and because we're targeting .NET 8, we've chosen the 8.0 tag for that. So this is our sort of default framework-dependent deployment. I expect this image to be pretty big. Let's go take a look at it. This is hello.net latest. Oh, that's the wrong one.
Yeah.
You want list.
You want Docker image. Yeah.
Yeah.
It's been a long day already.
Yeah. So this is 193 megabytes.
So not crazy, but also a bit big.
Yeah, and it's not exactly the kind of thing you'd want to be doing a lot of in production, where you're often billed on like network I/O for this. So let's see if we can shrink that down a little bit. Let's start with our app first, because that's the thing we can control most easily. We've invested in .NET in this concept of trimming your application, right? Which is a process by which the tooling can inspect the code that you wrote and find all the code that it references and remove everything else.
Right. So by doing that, we've now switched to self-contained.
Exactly.
Yeah, okay.
Yeah. So we should see a couple things happen as a result of this publish here. With the same command, based on the changes we made to our project, we should see it optimizing our assemblies for size, and we should see it becoming architecture and OS specific as a result. We also see it, the SDK, choosing a different base image for us. Whereas before, we were based on top of the runtime image, which includes all of the runtime bits in their entirety. Now we just need those same pieces you were talking about earlier that include things like TZ data and ICU. And
because if we were still using the runtime, we'd actually have two copies of the runtime in this image, which would not be all that helpful.
Yeah, it defeats the purpose a little bit. So let's take a look at this image instead, and I've called it latest still, so we can look at it again. We went from 196 megs to 144 megabytes.
So basically 50 meg reduction.
Yeah, and that's just all the pieces of the runtime that we didn't use.
Okay.
So that's all focused in our application. Let's see if we can target maybe the base OS.
Yeah, it's like, oh, can we do better?
So you mentioned these chiseled images before.
Yeah, I'm very enthusiastic about those.
Let's see what it takes. So you can actually opt into these very easily with the .NET SDK tooling. We have this concept called container family, which is a single property you can set that tells the SDK, sure, detect the runtime deps image, detect the runtime image, but use this chiseled variant of it instead.
Right, so jammy here means Ubuntu 2204, which was, its code name is Jammy Jellyfish. So you're basically saying, give me a particular version of Ubuntu 2204, and I would like the chiseled variant.
Yep, and I'm going to build now with that. I'm going to also do us all a favor and give this one a slightly different name using the container image tag property so that we can do a little compare and contrast.
Right, so every time we're making these changes, or this time, we're downloading a different base image and then still putting the app on top.
Yeah, so you can see how that container family property fed into the base image selection here.
So the SDK kind of knows the scheme. It's like, interpolated string, blah, blah, blah.
Exactly.
It probably literally is using interpolated strings.
Why wouldn't you? So with just that change from the full Ubuntu Jammy image to the chiseled one, we went from, what was it, I think 144 megabytes to 36.3.
Okay, so I'm hearing here, chiseled provides quite a bit of value.
It does, but there are trade-offs.
Okay.
All right, we should talk about those for a second. So when you've got a sort of standard Dockerized application that uses our runtime images or another full-featured OS as its base image, you can actually hop into those images and
general
poke
purpose,
around.
right? That's what we started with at the top.
Exactly.
Yeah, general purpose.
So what that means is you can do things like this. Entry point, bin, bash. You can jump into that container and poke around, right? You can look at the files that were deployed. You can do things like install diagnostics tools. You can mess around with that container.
Well, let's actually run the command.
Sure.
Oh, right.
We can't, which because of another aspect of the SDK
Yeah.
containers that we'll talk about in a second.
Yeah, we actually forgot about this again when we were practicing.
So these general purpose containers have shells on them. If we try this same flow.
Oh, you missed the key part. So go back into it.
Yep.
You forgot one thing.
Oh, wrong thing. Right here.
Type who am I.
Oh yeah. Why did that all happen? Why could we not touch the file? It's because we're not root, we're app.
Right, so how did that happen?
Well, this was in a partnership with the runtime team. The base images changed to sort of allow operating in a rootless mode of execution. That means the user that your application runs as by default does not have a whole slew of permissions that you may expect. You can't create files in the application's directory, as we saw. You can't run commands like app update because permission is denied. And depending on the image that you choose, like applications like apt or sudo may not even exist on the image.
Right. So if you had built this with Docker build, for example, doing the default thing, and definitely with .NET 6 or 7, this image would have been root, and you would have basically been able to do literally anything you wanted in that image.
Exactly. Now, you're in the driver's seat with all this. Just because the SDK defaults to using that new app user with limited permissions doesn't mean you're stuck in that mode. You can always tell your container execution tool, whether that's Docker or Kubernetes or anything else, that you want to operate as root. And if you do, then you can pretty easily do whatever you want. You can make files, you can do apt updates, whatever you need. So this isn't a one-way operation. We've got the mechanisms in place to keep you in control with that particular change.
Yep.
Yeah, so let's try that same exact flow with Chiseled and just sort of drive the point home about that we were trying to make there. So on a Chiseled application, we're going to try and hop in there with a shell because we need to debug our application, and we can't. bash does not exist on this image. And that, the reason it's not there is to reduce the size of the image. So all of these things sort of work together to reduce the attack surface area of your deployed applications.
Yeah, okay, so what are we gonna see next? So can we do better? I
We
guess
absolutely can.
Yeah. What's the thing from the Olympics? It's like better, faster, higher. Those are the things we want to do.
Stronger,
Yeah, stronger,
smaller.
Yeah.
We can actually try this new AOT thing that
Okay.
we've been talking about. So with this, we are going to go even one step further than trimming. And what's going to happen here is we should see a size reduction even further because we are compiling directly to native code, which I think typically means we don't have components like the JIT.
We do not have the JIT
at all anymore. So
we do have the GC still.
Yeah.
Are you going to change the tag?
Yeah, I am going to change the tag so
Yeah.
we can differentiate. So this one we will call AOT.
Yeah, and by the way, you don't have to use this container image tag. We're just doing that.
Yeah, we're showing all the fun little features.
Yeah. Right, so generating native code. This is, I think, the first time we've seen that.
Yep, this is a difference. This is the step beyond trimming here. So yeah, so you still have to trim, but then the stuff that is trimmed then becomes natively generated.
Yeah, and I think one thing to take home is we are in no way trying to say which one of these options is best for you. Like, we're not trying to say everyone should move to native AOT. That's not the message. It's really just we have a lot more options than we had before, and it's like, wow, what did we just see there?
We just went from 36 megs to 17.4.
Right, and this is uncompressed. Right, so in terms of pulling a container image from a registry to a container service, you wouldn't be pulling 17 megs over the network. It would be more like 10 megs.
Yep.
Because that's compressed payload at that point.
And like we sort of touched on before, that matters for two primary reasons. One is billing. Network I/O you don't do can't cost you. And the second is startup speed.
Yeah.
Smaller payloads are easier to download and faster to start up.
Okay, so what else can you show me?
There is one further step. So if we think about our OS and our application, we've gone, I think, as far as we can with our application now.
Yeah.
There's one more step we can do with our OS, and that is using a version of our base image that is ruthlessly optimized for AOT.
I heard a rumor that this was available.
So this is bleeding edge stuff here.
Yeah.
So every other image we've been using has been under the sort of fully stable dotnet bucket, but this is under nightly. This is the runtime deps image, and we're going to choose the AOT variant of the jammy chiseled image that we've been playing with up until now.
Right, because our AOT runtime doesn't have the same dependencies, just fewer than the Core CLR runtime JIT one. Okay, so let's try this out.
So just a quick note, we're using this container base image property here because this lets us exactly specify the base image that we want.
Full manual mode.
So as always, the story is helping you do...
did you save that?
Oh, that is a great question. I did not. Thank you.
Okay, we saved a couple minutes there.
Yeah. The story, as always, is depths.
Yeah.
Giving you lots of tools here, but making the sort of default pathway easy and correct.
Right. So we're literally generating the exact same app this time. There's 0 changes to the app.
Only the operating system.
Yeah.
So, drum roll, please.
AOT deps.
So before we go, it was 17.6 before.
Okay.
We are at 15.1. We saved 2.25
two more megabytes.
Yeah.
Okay, awesome.
I'm pretty happy with that.
Okay. So, one of the things that you and I just can't seem to agree on is you have an x64 laptop and I have an ARM64 laptop. And so your x64, I just couldn't do it. I wanted to use this ARM one. So how can you kind of help me out with that?
Sure, yeah. So .NET developers are used to publishing applications for different architectures and different operating systems. Yeah. They should expect the same here.
Okay, so it works with container publish.
Yep, there's a couple caveats. The AOT capabilities here are fairly restrictive on the platform that you can AOT natively for. So we're just going to back that step out for a second.
Right. So can be made to work. We're just not going to demo it at the moment.
Yeah, we've got samples. It takes a little bit of setup, but it can be
It's
done.
actually in the workshop how to do that.
Yeah, so this should be good. We still are fine with trimmed. We're still fine using jammy chiseled. We are just going to add one more flag that most .NET developers should be familiar with. We're going to tell the application to target ARM64 instead. And I'm just going to call this one instead ARM64 so we can identify it. And just like specifying a runtime identifier with -R or an operating system with --OS, the system understands what you mean here, and it will help you make an image for that correct architecture. So let's run this one locally real quick. And even though I'm on an x64 architecture machine, Docker supports emulation. You can see it saying here that we're running on ARM64 emulated, and we do in fact get that output. So let's push this to somewhere that Rich can get it.
Yeah, so I heard that your OCI published stuff can actually push to a registry as well.
It absolutely can.
As if everything we showed today wasn't enough.
Yeah, so we've been pushing to a local Docker daemon that I've got going right here. You could also push to Podman or to a file if you want. But the most common way people interact with containers is external registries. So we 100% support that. We're going to push to an Azure Container registry that I have set up right now, .azurecr.io. And we're just going to get that push going. And because we've told the system which registry to push to, instead of pushing to Docker, it will push up to ACR. So this will look very similar, except it won't. See, Husk, container testing. Because I forgot to log in again.
Oh, yeah. Yeah. OK. So, yeah, I was going to ask you that. So clearly, the container registry is a protected resource. So you need credentials, passwords, all that kind of stuff. So
it would also help if I typed it correctly.
Yeah, OK. Right. So I think we're taking advantage of the same underlying mechanism as Docker login, I think.
Exactly.
Yeah.
Any system that can correctly authenticate to Docker should also work for our system. And it looks like it did. Some slight visual differences in the tool tell us that. So all of this is what we've been seeing before. We're building this image with this tag on top of this base image. But this next bit that you see is saying that we've uploaded layers, the actual Docker file system items, to the Azure CR that I specified. And finally, we've pushed hello.net ARM64 to my destination.
OK,
Rich?
So now here's the big test. So now we're going to go to look at my machine. I'm going to run Docker run as soon as the machine flips in the video, and see if I can pull this from the registry.
Don't forget to zoom in a little bit.
Yeah, I did zoom in. Maybe I'll open up actually a different, since we seem to have a little bit of time, I will open up a different terminal. I actually always have trouble with this. OK, maybe that's not going to work because I'm still seeing that there. So what we could do while we're waiting is, well, actually, you could pull it.
Yeah, absolutely.
Yeah, you could pull it. It won't quite do the exact same thing because we're going to rely on emulation again. But we could just at least demonstrate,
Absolutely. So this will work for me because I'm authenticated. It would work for Rich because I've previously set up my Azure Container registry to allow anonymous pull. So if we pull this and we go hello.net ARM64, this is a normal Docker pull. The base images for the runtime deps and all already exist. We pulled the new layer, and now
we can just run it.
We're just going to run it.
OK.
Same emulation message as before, same emulated result as before. That was the round trip.
Right. So the only thing that would have been different on my machine is we wouldn't have had that warning message.
Yep,
yeah.
Exactly.
So we've just got slightly less than a minute left. I think the cool thing to do would be to show the workshop.
Oh, yeah.
Yeah, just to give people an idea of what's there.
Sure. You want to see it online or you want to see it?
No, online.
OK.
Yeah, we got in the web browser. Yeah.
Yeah, so Rich has got this workshop.
That we worked on together.
Yeah. Under his name here. You want to walk us through what we're seeing here?
Yeah, so we can zoom that in a little bit. Basically, what we did is we thought of everything that you would really need to know to get started. It's mostly about publishing OCI images, but it's got a ton of, just open up one of the files, doesn't matter which one.
Sure.
And it's got, this one has all the properties that you would need to use, and it's got a ton of instructions to get you started. Okay, well, thanks everyone for listening to the talk. Chet and I and a bunch of other people worked a ton on this stuff, and we're really glad to see you start to use it.
Oh yeah.
Thank you.